Hi everyone, so today we're going to write equations of rational functions based on certain characteristics. So here we have to write an equation of a rational function that has a vertical asymptote at x is equal to -3. So one thing to remember always, we're writing a function, so we want to have f of x, something in the beginning that's going to show that it's an equation, so f of x, g of x, and it is a rational function, so we are going to have a fraction. So with the vertical asymptote, you have to remember that we're looking specifically at the denominator. So I need to think about what expression would be in the denominator that when I set it equal to 0 would get me an answer of x is equal to 3. So easiest thing to think about is x is equal to 3. You could do 2x minus 6 if you wanted to, any combination of any expression that as long as you set it equal to 0, your answer would get you 3. And you could put anything else in the numerator. So you could have a number, we could pick 5, you could have 2. So with this particular function, we are looking specifically at the denominator and that the expression is going to equal 3. With this function, we want a horizontal asymptote at y is equal to 0. So remember with horizontal asymptotes, we're looking at degrees, and it is bottom heavy. So the degree that's in the denominator has to be bigger than the degree in the numerator. So you could have, let's say, x squared plus 1. You could have x cubed plus 1. And then you could have an x in the numerator. You could, again, have a number if you wanted, like 3 or 4, as long as the numerator has a smaller degree than the denominator. In this function, we want an x-intercept of 2. So we have to make sure that our numerator is going to have some expression that's going to get me 2. So I could do x minus 2, for example. So you could have anything else in the denominator, like an expression, x minus 1. You could have a number like 7. So as long as we're focused on that numerator, getting us an x-intercept of 2. In this function, we want a y-intercept of 5. So we think about a y-intercept. When my x is going to equal 0, then my answer has to be 5. So if I plug in 0 for x, that overall answer is going to simplify to 5. So we can, again, you could have x squared plus 5 and then x plus 1. So then when I plug in 0 for x, when I simplify, I would get 5 over 1. Again, any combination. If you don't want to have those exponents there, that would be fine too. But remember, my overall answer would have to get me 5. So with this function, we don't want a horizontal asymptote. So we have to remember with horizontal asymptotes, we're looking at degrees. And we want to be top heavy. So the degree in the numerator has to be bigger than the degree in the denominator. So we could choose like x to the 5th power. And then again, in the denominator, you could have 3. You could have x squared as long as the numerator has a bigger exponent than the denominator. Here we have an equation of a rational function that has to have a vertical asymptote of x is equal to 1 and x is equal to a -1. So we want two vertical asymptotes. So remember, vertical asymptotes, we're looking at the denominator. So what expressions could I have in my denominator that would get me two different answers of 1 and -1? So I can make two expressions, right? X minus 1 and x plus 1. And again, whatever's in the numerator, you could put a number. You could put an x squared if you wanted to. Again, we're mainly focused on the denominator. So here are some things for you to remember. Remember, finding x-intercepts, we're looking for the zeros of the numerator, and then finding the y-intercepts, we're looking to see what our expression will be when I plug in 0 for x. Now I hope you found this video helpful and you're able to now create equations of rational functions based on certain characteristics. Thanks for watching and see you next time.